again, I'm Chris Costello, and I'm going to basically be, this isn't really a research talk. It's a colloquium, so that the idea is to, or at least my idea was to kind of introduce you to some of the projects that I've been working on surrounding sustainable fisheries, and in particular using kind of a profit motive or incentive-based fisheries management as an incentive or as a mechanism to reform fisheries, both locally and around the world. And I'm going to talk about some of the research I've been engaged with in that area, and also about some of the specific fisheries that we've been working with. And I noticed there are a number of fishermen in the audience, and as John Ugaretz pointed out, it's not even windy, and the fishermen are here. So we got to wonder about their incentives and their motives here. But welcome to everybody. So, you know, this is a crowd that I don't really have to, I'm preaching to the choir here, but, you know, fisheries around the world are in decline, and that's true whether you think of a fishery as kind of an ecological unit or as an economic unit. Most of the research that's come out recently has been on the ecology side, and what people have shown is things like, you know, large predatory fish are in decline, ecosystems around the world are in decline, biodiversity is in decline, or native biodiversity is in decline. And this figure here is from what I think is probably the most famous paper. It came out a couple of years ago in Science by Boris Worm and his colleagues at Dalhousie University. And what they showed is they looked at basically all the fisheries in the world, in all 64 large marine ecosystems around the world. And they showed that fisheries are increasingly collapsed. So this vertical axis is the collapse rate, and this is time. And they went from 1950 all the way out to 2003 and showed that sort of regardless of which ecosystem you look in, fisheries are increasingly collapsed. And today about a third of fisheries around the world are collapsed using their measure of collapse. And they didn't really go any further. They didn't ask, you know, why are they collapsing? They didn't ask, what can we do about the collapse? Although there's kind of an implication that, you know, fishing's bad, so we better stop fishing if we want to stop the collapse of fisheries. That's the kind of the ecological side. And if you look at the economic side, there's sort of similar statistics. No big studies like this published in Science along these lines, but similar statistics about job loss or loss of working waterfronts and general loss of profitability to fisheries. So, you know, my colleagues and I, and among other people around the world, have been very interested in sort of why this is happening and what might be done to solve this problem, short of just banning fishing. Okay, that's kind of the easy solution that isn't very satisfying, because, you know, we like fisheries, we just don't like fisheries collapse. So we kind of went back to first principles and started looking at what are the incentives provided by the way that fisheries are managed around the world. What are the incentives to fishermen to behave in different ways? And there are lots of different ways fisheries are managed, and it's hard to sort of generalize, but the most egregious version of mismanagement of fisheries is what you might call the open access fishery, which is essentially a free-for-all. Anybody who wants to come in can fish. And basic theory that, you know, was developed in the 1950s turns out to be true, that fishermen are going to enter until the fisheries collapse, and you get an economic collapse where all the rents are driven out of the fishery. If you've taken my class, you should be well aware of that. But you also tend to get this ecological collapse, okay? But you might say, well, but if you look around the world, most fisheries are not managed with open access. There's better management than that, okay? So why do we still see fisheries collapse? And it turns out that, in fact, most fisheries are managed with some degree of control, okay? And the typical way fisheries are managed around the world is there's some fishery manager who has some idea of what the fish stock size is, and they say, well, you know, we don't want harvest to be too high this year, so we're going to limit the season length. And we're going to tell fishermen, you have to have a permit to go fish. You can catch as much as you want, but here's the season length, okay? And so what I do, so we all have permits. We all go out. We try to catch as much as we can in that period of time. But I know that, you know, the season's only 2 months long. I better buy a bigger boat this year or hire more crew or use bigger nets than you so I can catch more. You do the same thing, and we get what we call a race to fish. And it leads to all these kinds of problems. Excessive investment, that's kind of an economic problem. You get very dangerous fishing, so people are going out even if the weather's terrible. Destructive fishing practices, which may, damage seafloor habitat or damage spawning habitat, those sorts of things. You get shorter and shorter seasons and poorer quality fish, which leads to lower prices. So there's sort of economic and ecological reasons that even under this management system that's probably the most common one in the world, you're going to still expect to see these kinds of results, and in fact we do. So again, the theory is that even under managed fisheries, okay, you're going to see declines in the stocks and declines or a complete collapse of the economic value. Okay, so what I want to introduce now is a group of people that have formed something called the Sustainable Fisheries Group, which was founded with major support from the Paul Allen Family Foundation. Some of you have heard of this work, and there are a number of us that are principal investigators and a number of co-collaborators, some of which are here. And the basic idea is that, everything I've said so far is well known. I didn't come up with really any of that, okay? So it's well known that fishermen respond to incentives. It's well known that the way fisheries are managed, most fisheries are managed around the world, don't provide the right incentives. So it's no surprise that we see these collapses that I alluded to earlier. But what isn't very well done is taking sort of novel science and novel solutions and partnering with people who can actually implement them. And that's what we're trying to do in the Sustainable Fisheries Group. And one of the things I'm going to do today in the just next 15 or 20 minutes is tell you about some of the projects we've been engaged with. Our main non-governmental organization partners are the Environmental Defense Fund and the Nature Conservancy. I'll tell you about some projects we've worked on with them. And we also have a number of fishermen partners, both locally and in Mexico, in Alaska, and in other places. Whoa. Okay. So I've talked about incentives. It sounds good. You want to provide, or at least what I've really said is that the current management system does not provide the right incentives. Well, how do you provide the right incentives? What do you do? Well, there's a broad class of pretty new fisheries management institutions called catch shares. That's the one I want to focus on today. And it's the one that most of the research has been conducted on. And I don't want you to think of catch shares as one little specific alternative, like either a fisheries managed with this or it's not. It's a broad class of things, and I'm going to sort of give you a sense of that scope throughout this talk. But the basic principle is that you want to provide some kind of ownership right to fishermen. So we're entrusting fishermen with some sort of responsibility to do the right thing, but we're providing the right incentives for them to do that. And so, and I'll be a lot more specific in a second, but the idea is that if you provide security to fishermen, think of yourself as a college student who's renting an apartment, and you're trying to decide, should I invest $10,000 in new energy-efficient windows or not? I know it's going to save me money on my long-run electricity bill, but I might be out of that apartment next year. There's no way you're going to spend $10,000 on energy-efficient windows when you're renting as a college student. Compare that to the case where you own your house, okay? Well, whether you intend to stay in your house over the next 2 decades to recoup that investment or not, the value of your house goes up when you invest in those windows. So you have because you own that thing, you have a much stronger incentive to invest in it. And I just can't help but tell you this little anecdote that I learned from Bob Deacon on milkshakes. So this is a totally different way to think about it, but pretend you've got a milkshake, okay? You got a bunch of kids in your house, and you want each kid to have some milkshake. So what you do is you take this big milkshake, you give each kid a straw, and you stick all the straws in the same milkshake. Well, what is their incentive? Their incentive is to slurp like hell. They all get brain freeze. Everybody's drinking more than they should and much faster than they should, and nobody's happy at the end of the day. And where you could have just taken that big pitcher full of milkshake and poured it into 5 cups, and maybe the cups are of different sizes depending on the size of the kid, and basically that's what a catch share is, okay? It takes the total amount and it divides it among the participants in a way that makes everybody a lot happier at the end. And I'll try to carry that through with much more specific examples. But the idea is to provide these incentives for long-term stewardship rather than just short-term profitability. And the map on the left is, the most common form of this catch share is called an ITQ fishery, and I'll describe that in more detail in a second. But this is a map of where the ITQ fisheries exist in the world. And these are the places where catch shares in general have been applied, among some other places, but those are the prominent places. Okay, sort of one of the two key themes of this talk is that catch shares can take many different forms, okay? And it's all about getting the incentives right. And what I've done is I've divided catch shares into three main classes. And so I'm going to describe those now, and I'll give examples in a minute. The first and the most common is when you have shares of a scientifically determined catch. So scientists are monitoring the population of a species, and the population's high this year, so they can allow a high harvest. And what they do is they say, here's the total catch. This is the milkshake's big this year. Let's divide it up among the fishery participants this year, and it's a big number that we can divide up. If it happens to be low, then it's a small number we can divide up. But it's shares of that scientifically determined catch. The second version doesn't divide up the total catch, it divides up the area. So you've got the whole coastline, and what you do is you say, okay, this person or this cooperative or this community gets exclusive access to this share of the coastline, okay? So you're dividing up space rather than the catch. And finally, you could have shares of the management interest. So instead of a manager saying, you will do this, there's some share in that. So the manager may say, well, here's a general framework, and now you as a cooperative or you as a community, as a concession, gets to make some management decisions on your own. So it's shares of the actual management of the system. And I've given just some places where these things exist, and I'm going to give some examples now. But before I get to the specific examples, I guess the key point here is that which of these three should you pick, and then within one of those, so let's say you go with shares of the catch, the first one, how do you know what the design elements should be? And the key thing here is that, that of course the design is going to drive the outcomes. And the outcomes could be economic outcomes, ecological outcomes, or social outcomes, and there are probably others. And so before you sort of set one of these things up, what you want to do is say, well, what is our objective? I tend to look at this through kind of an economic lens, and we tend to always think of economic objectives. And it's pretty easy to, if you know the characteristics of a fishery, to say, well, which of these three is the right pick, the right match, if you're trying to maximize profits to fishermen. That tends to be one of the things I look at. But let's say you were also interested in maintaining the waterfront, the historical working waterfront, or the same fishery participants that have been there forever. Or suppose you're also interested in protecting a spawning area. Which of those objectives is most important to you should help inform how you design the thing in the beginning. And I just want to kind of give you a contrast of two examples. The halibut fishery in British Columbia and then in Alaska, and then the orange roughy fishery in New Zealand. These are both managed with catch shares. They're both managed with the individual transferable quota that I mentioned earlier, the ITQ. The halibut fishery in 1991 in British Columbia, it's a very profitable fishery, fairly sustainable fishery, switched over to ITQs primarily for economic reasons. Okay? In 1991, the season length in British Columbia was either 4 or 5 days long. So the whole season's catch was harvested in 4 or 5 days, and it had to be that short because of this huge overcapitalization. In 1991, they switched to these catch share systems, and immediately the season length went out to like 5 or 6 months, and now it's about 8 months long. And Alaska followed suit in 1994. Everyone said, this is the poster child of success for ITQ fisheries. Now, you can contrast that with, hi Charlie, with the orange roughy fishery in New Zealand, which has been, frankly, a dismal failure. But you have to dig a little deeper to know why. It's not a failure because catch shares are a bad idea. It's a failure because of, first of all, scientific uncertainty was not factored into the way the thing was designed. But most importantly, instead of giving shares of the catch on a percentage basis, so that if the stock was low, the total catch could be low in a year, they allocated shares on an actual quantitative basis. So they guaranteed fishermen the right to harvest a certain amount of fish. And when they discovered that the population was lower than they thought, they couldn't rescind on that, and they ended up over-harvesting the stock. So you have to be mindful of the design in order to achieve whatever objectives you're trying to achieve. Okay, so let me walk through these three main classes of catch shares and provide a few examples. The most common one is this ITQ, the individual transferable quota. Now, many of you are probably familiar with this. Many of you probably know about cap and trade for air pollution markets. Okay, there are a number of these around the country, and there's talk of having these for carbon. And under a cap and trade system for air pollution, the cap is usually constant over time. Under a cap and trade system, an ITQ system for fish, the cap can fluctuate. This is the orange roughy example I was giving earlier. And so what you own as a fisherman is a percentage of the total catch. So Jono might own 2% of the total allowable catch. If the catch is high, he gets 2% of a big number. If the catch is low, he gets 2% of a smaller number. But he gets that in perpetuity, and that's what provides the incentive for long-term stewardship. So now he says to himself, okay, 2% of, I'd like the catch to continually go up over time because, in a sustainable way, because that will increase the value of my 2% share. And he could sell me 1% if he wanted to, or he could keep his 2%. He could buy an extra percent and have 3%. So these things tend to be transferable, but the cap fluctuates from year to year based on science. And so you often hear this argument that under a catch share system, you eliminate management or regulators, and that's just not the case. In fact, I would argue there's an enhanced role for science, because now Jono says, listen, you managers who are deciding on the cap, you better do it right. If you don't get it right, the value of my 2% share goes down. Okay, it's like when you own, if you own stock in Google, you want Google to be run in a way that maximizes profits. Okay, and so as a fishery participant, you have now an incentive in the long-term viability of the fishery, which you did not have under the status quo system. Now, this thing is not without its challenges. The two big ones are, how did we decide that Jono got 2% and not 1%? Or, maybe Jono should get 5%. So how do you do this initial allocation? One way to do it is through auction. So everybody could have to pay for it, but people object saying, well, I've been able to fish forever without paying that. Now I've got to pay $500,000 just to go fishing. The more common way that it's done is to look at the history of your participation in the fishery. And if he's historically caught 2% of the total catch, he gets a 2% share of the 2% share of the quota. Another big argument people make is that this will lead to consolidation. So all the mom and pop firms that are operating down on the waterfront that have been there for decades are going to get bought up by the big corporations that come in and are more efficient. And we could debate whether that's a good thing or a bad thing. If you allocate based on historical participation, then you don't have to sell, but people tend to sell if someone who can pay them a higher price than they're willing to accept. So consolidation can be dealt with in various ways. One of the things they do is they put a cap on the most anyone can own. So maybe Jono wants to ramp up to 5%, and maybe there's a cap at 4%. He can only get up to that level. He can't own more than that. So there are various ways to handle the consolidation problem. Yeah, Hunter. knowing how many fish are there is a challenge now. So that's not a new challenge under an ITQ system. Now there are fisheries, maybe we can talk about this after, but there are fisheries where they actually don't have to know how many fish are there now. So they don't set a quota at all. And for those fisheries, an ITQ may not be appropriate for that exact reason. Now, there are no ITQ fisheries on the West Coast right now, but in about a year that will no longer be true. The West Coast groundfish fishery, which is a federally managed fishery in California, Oregon, and Washington, is undergoing transition right now to an ITQ. And it has a number of very innovative features to try to get around some of these problems, and I'll talk about it in a minute. Okay, the second class of catch share fisheries is these TERFs, these territorial user right fisheries, where instead of carving up the catch, you carve up the coastline. This picture on the top is a group of turf fisheries in the Vizcaíno region of Baja California that I've worked with, and each of these little polygons is a different turf. It's a concession granted to a different community to manage the fish that reside in that area. One of the things people say is, well, you know, if we go to catch shares, what is that? Isn't that inconsistent with marine protected areas? You know, we like marine protected areas because they preserve the stock, but you know, then how does that jive with the catch share idea? And I think when you think about spatial management as you have to with turfs, there are a number of synergies with marine protected areas. And so let me show you a little simulation here. This bottom picture is from a project that originated here called Flow Fish and Fishing, which basically tries to model how connected any two places are in the ocean via the distribution of fish. And so if you think about that top picture, you know, if one of these, let me get a pointer, if one of these turfs, let's say that the flow goes this direction, okay, goes up the coast, then the more this guy harvests, the less fish there are in this patch, and this patch. Okay? So there's a connection between the patches that has to be understood in order to manage these turfs. And so this is the sort of thing we've been doing. And this is a little simulation of the Santa Barbara coastline. And these are simulated larvae that leave near shore sites that have good spawning habitat, and we track them over time and try to figure out where they end up. Okay? So we basically can map, this is Mexico, this is Santa Barbara, but you can map how connected any two of these places are, and then we could say, okay, suppose you have a turf system like this and an MPA. Well, how important are the larvae coming from that MPA to different turfs? And so this sort of science can help overcome some of the real scientific challenges in setting up a turf system. And turfs are not common in the U.S. There are a couple of small ones, but they aren't common. But they're being proposed in lots of different places right now. And the last class is this class of cooperatives, where basically a group of fishermen can cooperate on things like harvest, monitoring, marketing, and ultimately can go to what we call a co-management system with the government. So instead of being told what to do, they have a say in how the fishery is managed. And by given a say, when the government or whoever the regulator is gives them a say in management, that provides a stake and a long-term incentive for better management. And these are just some examples of places that are managed with cooperatives. Okay, what I want to do now is, I'm going to go for maybe another 15 or 20 minutes, is just really quickly walk through 5 or 6 one-slide examples of fisheries that I've been involved with that kind of use innovative management approaches, management catch-share approaches, okay? The first one is the Chignik Salmon Cooperative, and Bob Deacon and I have written a couple of papers on this cooperative, and they did something that at least to our knowledge, has never been done before. In 2002, the fisheries manager said, what we're going to do is start up a fisheries cooperative, and anybody can join the cooperative. There are 100 permit holders in this fishery. And anybody can join, and if 70% of the people join, they get a 70% allocation of the total catch. So they take the total catch, give 70% to those guys, give 30% to the so-called independent fleet, the fishermen that don't join the cooperative. And then the guys in the cooperative can coordinate along the lines of what I talked about earlier. It turns out 70% did join, so 70 out of the 100 joined this cooperative and almost immediately got a higher price, lower cost, longer season length, higher quality product, and the permit value, these are all empirical results that Bob and I have shown with Nick Parker in this paper, the permit value substantially increased during that period. Now, it turns out this thing was shut down in 2004. But the kind of lesson that we learned from looking at those empirical results and working with these guys is that you often will need to mix, so this allocation, which is basically what you get in an ITQ, where you allocate to either sectors or groups or individuals, you often need to mix that with a cooperative in order to achieve the highest benefits. And in this case, the reason that worked is that, you know, the way, you probably know about salmon, but salmon live out in the ocean, and normally they're harvested out in the ocean, but they swim in towards port to migrate upstream. When it's a competitive fishery, a free-for-all, everybody keeps racing farther and farther out, and that significantly increases the costs of harvesting. And so what the cooperative was able to do is take 70 fishermen's worth of licenses and harvest that with only 12 fishermen. So the rest of the guys could go off and fish in another fishery or do something else, and they shared profits, so that was profitable for everybody. And instead of racing each other farther and farther out, those 12 guys just sat in near port and waited for the fish to swim to them. So they significantly increased profits by cooperating. Carla, did you have a question? That's a great question. The answer is no. So permits, if you're in the cooperative and you sell me your permit, I can either join the cooperative or not. It's up to me. So that makes it even more of makes it a stronger result, because all the permit values went up, whether they were in the co-op or not. But just the idea that you could join a cooperative raised the permit value. Okay. I mentioned these earlier, and I showed that one picture of the Baja California Concessions. This is a co-management system, and it's the thing that's innovative about it is that they're concessions. So what they do is the federal government goes to each of these little communities, and they say, we think you're doing a pretty good job managing your fishery. We're going to let you continue to do that for 20 years. And you can pretty much do whatever you want. And 20 years later, we're going to come back, and if you're still being good stewards of the resource, we're going to renew you for another 20 years. Okay? And so at least over a 20-year period, this provides some incentive to manage in a sustainable way. It's essentially granting exclusive access to the resource for 20 years. Now the problem is that there's some uncertainty about whether you'll get renewed or not. And so what Dan Caffeine and I showed is that if, is 20 years long enough to get you to do the right thing is an open question. And for species that are fast-growing, like lobster, it turns out that it is. And empirically, when you look at how they're doing, the lobster fishery is thriving. It's Marine Stewardship Council certified, and the population's thriving, and the fishermen are doing well. But for slow-growing species like abalone, which is also managed this way, it's not long enough. So the 20-year length is not long enough to provide the right incentives for long-run stewardship of the resource. So you have to, basically what we found is that this 20-year number has to change, has to get longer for slower-growing species. Okay, I sort of alluded to this connection between turfs as an innovative way to manage fisheries and MPAs as a way to protect fish as maybe being consistent with one another and not in contradiction with one another. And I'll just start off by, I think this is probably well known by now, but by stating that it turns out marine protected areas may actually be good for profitability if they're sited appropriately. So when you have a source sink kind of a system, kind of an ecological system, it turns out that you want to protect the sources and you want to fish in the sinks. Okay? And so Steve Pulaski and I recently showed this kind of in a theoretical model that if your goal is to maximize profits to fishermen, and you have a fishery that's spatially connected in the way that I showed earlier with that little simulation, that in most cases like that, marine protected areas, if sited properly, actually can increase profits to the fishery. But when you start to think about turfs, that can change the incentives for MPAs. So imagine you own a turf, and the regulator, John Ugaretz, comes in and says, we're going to put a marine protected area right next door to you. Well, you like that all of a sudden if you own a turf. Okay, whereas before, when it was a free-for-all, you said, come on, man, you're taking away all this area that we used to harvest in. Now you're saying, great, please put a marine protected area next to me, because my catch rate's going to go way up because of spillover from that marine protected area into my patch. So all of a sudden, when you use turfs, the incentives for sort of advocating for or against MPAs significantly change. A territorial user right fishery. Okay, so one of the things that, again, Dan Caffeine and I have been looking at, so this problem where, if I over-harvest and my fish used to spill over into your patch, that's a problem you're going to have with turfs in fisheries like this. But that's not a new problem. That problem it's the same problem that you see with extraction of non-renewable resources. So if we both own mineral rights to a common, let's say, an oil pool, okay, it's the same problem. Should we both drill, and then I'll drill a little faster because you're going to come in and try to drill and impose an externality on me. People end up drilling too quickly, just like fishermen would end up extracting too quickly. And the solution they use for non-renewable resources is something called unitization. Actually, Gary Leibkab is one of the world's experts in this. So it turns out unitization tends to work for oil and gas. And the reason it works, and what it is, first of all, is if Jono and I both own mineral rights over an oil pool, what we do is we say, well, if anybody drills into this oil pool, we have to share profits. So now there's if he's already drilled, there's no incentive for me to drill because I already get a share of his profits. So what about the same kind of concept for fisheries? Why wouldn't unitization work in turfs that are spatially connected? And so Dan and I have been looking at that, and it turns out that it could work. I mean, there are compelling reasons to think it could work. In an empirical example, we showed by unitizing, you can get about a 300% gain in profits to the fishery. And kind of most striking, it's possible that you can get individual turf owners saying, I volunteer to close my patch down. Now, why would someone do that? I volunteer to close my patch down because if, let's say I happen to have the turf in the source region, let's say in the spawning region, it's more profitable to me as an individual to close my patch down, seed the whole rest of the area with lots and lots of fish, and I get a profit share through unitization of those fish that have dispersed out, okay? So you actually can get a situation where you have privately optimal marine protected areas that are not imposed by the government in a case like this. I'm not saying that would always be the case, but even if they aren't full MPAs, there's certainly an incentive to reduce your harvest to a more sustainable level. Okay, I'm going to skip this one because I already mentioned it. Morro Bay Harvesters Cooperative. This is something we've been working on with the Nature Conservancy. Actually, they're the lead, and we're sort of more consultants on this. But a few years ago, the Nature Conservancy approached us and said, we're interested in purchasing federal permits for the West Coast groundfish fishery that reside in Morro Bay, just north of here. Okay? And what we'd like to do is ask your advice. They're talking to us. Ask for your advice on how we should acquire those permits, and as a quid pro quo for paying a relatively high price for those, we want to ask for a huge no trawl zone to be designated up just north of here. And they were successful. They went to, I think they now own either 11 or 13 permits in this fishery. And what they did is they went to fishermen and they negotiated on a one-on-one basis to acquire their federal permit and their boat in exchange for everybody agreeing to this no trawl zone up in that part of the world. It doesn't mean you can't fish there. It means you can't use trawl fishing gear there. So they picked especially sensitive habitat that they thought trawl gear might be damaging to. So then now the Nature Conservancy, an environmental group, owns a bunch of fishing permits, right? And they happen to own fishing permits in a fishery where it's literally illegal to use any gear besides trawl gear. Okay, if you're a fisherman in the federal West Coast groundfish fishery, you cannot go use a trap or a hook and line. You have to use a trawl, which is, I think most people regard as being a less environmentally sensitive fishing technology. So the first thing they did is they applied for something called a gear switching provision with the management authority, the Fisheries Management Council, and that was approved for 2 years. So now it's legal for them to use their permits to fish with other kinds of fishing gear that are much cleaner. That was approved. And now they actually have formed a harvesting cooperative. So they've leased back to fishermen or engaged fishermen to work with them to go and experiment with different kinds of gear. Can we make a profitable business out of using hook and line or trap gear to catch sablefish or to catch blackgill rockfish and access this high-end green market where we may get paid twice as much money per pound as the same species that's caught with a trawl. And so that's an ongoing experiment. But suppose it turns out in the affirmative. Suppose this actually is a profitable enterprise. Then is it scalable? Could the entire West Coast groundfish fishery move to something that's cleaner and lower volume but higher value and potentially more profitable than the trawl fishery that we currently have? And I think this is the last one. This is actually a little bit different because the vaquita is not something we eat. It's something we kill when we fish for shrimp in the upper Gulf of California. So this is one of the rarest marine mammals on Earth. The current estimate is there's about 200 of these things left, and this is in the upper Gulf of California. They're in a very small centralized location, and the problem is that the way shrimp are harvested in this part of the world is with something called a set gill net. So a gill net is set out, and the fisherman leaves, and he comes back, and the shrimp are caught in the net. But it turns out the vaquita also get caught in the net and drowned. This is a picture of a drowned vaquita. So we were contacted by a bunch of different organizations, including the Mexican government, a couple of NGOs in Mexico, and NOAA in the U.S., the Marine Mammal Protected Mammal Division for NOAA, to try to help come up with a solution for this problem. Okay? And a lot of international NGOs have been working on this for decades. So I'm not saying we're the only ones working on this, but we have been able to give some advice about how to rationalize the fishery and go from basically a free-for-all where, yes, you had to have a permit, but there was no enforcement, and there were all these people that claimed to be historical participants that didn't have permits who were allowed to fish and this sort of thing, and they weren't transferable. We were able to turn that system into a rationalized system where you had to have a permit to go fishing and there was better enforcement. And then we started up this Sustainable Fisheries group I mentioned earlier, started up this alternative gear SWAT team that consists of fishermen from Oregon, Washington, and California, and from Mexico. And these guys are all collaborating to come up with new fishing technologies that are just as efficient at catching shrimp, but don't catch the vaquita. Okay? And the current gear they're working with is only has about a 10% loss in efficiency in catching shrimp, doesn't catch any dolphins. Okay, so then the idea is to take that and say, well, now fishermen will pay you, will compensate you for switching over to this gear, and in that case, you'd have to pay them 10% of what they would have earned otherwise. Okay, so those are kind of the on-the-ground or on-the-dock experiences, some of them. There are many, many other projects, a lot of local ones I didn't even mention, that are kind of ongoing. But we've also been engaged, in addition to the papers I've mentioned, in some kind of global analyses of what is the effect of catch shares. And the one that's gotten the most attention is this paper that I wrote with Steve Gaines, who's the director of the Marine Science Institute next door, and John Lynham, who was a PhD student here, is now at University of Hawaii, called Can Catch Shares Prevent Fisheries Collapse? This came out in Science just a few months ago. And what we did, remember that first graph I showed you from Boris Worm's analysis? Well, that was the one that had collapse rates increasing over time. Currently, about a third of fisheries are collapsed. After that paper came out, I mentioned the Paul Allen Family Foundation. We actually got a call from Paul Allen, who reads the newspaper like everybody else. And he said, what's the connection between this paper that is getting all this press, this is the Boris Worm paper from a couple years ago, and your project that we just funded? Is there any connection? What's going on? And we sort of scratched our heads and said, well, that's about fisheries collapse. And they're talking about, kind of an ecological thing. What we talk about is solutions. So no, there's really no connection. And we thought about it and said, well, gee, maybe we could collect the same data set and look at the fisheries that are managed with catch shares, the fisheries that aren't managed with catch shares, and see if you get the same result. Are the ones managed with catch shares also declining towards collapse in the same way? So that's what we did, and this is the graph. So let me explain this. There's a lot going on. If you first focus on this black line, this is just literally just replicating the Boris Worm's result. So this is the collapse rate over time. So it goes from 0 up to 30%. Collapse rate over time of all the fisheries that are not managed with ITQs. Okay, so Worm's result would have actually been slightly lower than this, but basically it's the same as what Worm got. That's from 11,000 fisheries, all marine ecosystems in the world, data from 1950 to 2003. When you separate out the group that eventually adopted catch shares over that period, that's given by this dotted line, okay? And what you notice is that up until about 1980, it was also on a steady downward decline. But in about 1980, it sort of reverses direction and, at least statistically, flattens out, okay, after about 1980. Well, what happened in 1980? This dashed line is the adoption rate of catch shares around the world. So at least this graph is sort of suggestive that at the same time we started adopting catch shares, the catch share group completely flipped direction and certainly flattened out, if not sort of increased, or the collapse got less bad for that group. So what were kind of the conclusions of that study? I'm not going to go into the details of our analysis, but the first main result is that catch shares, statistically speaking, catch shares do prevent fisheries collapse on a global basis, and that holds across whether you look at whichever taxa you look at, whichever ecosystem type you look at, and that the longer a fishery uses a catch share, the less likely it is to collapse. And we did a number of robustness checks. For example, you might say, well, maybe the fisheries that eventually adopt catch shares are just inherently different, that they wouldn't have collapsed anyway. But if you go back to the graph, they were on the same kind of trajectory towards collapse as all the other fisheries, so that can't be the case. Maybe the catch shares were implemented in the ecosystems that are easily recovered, okay? Or for genus that are easily recovered, or species that are easily recovered. Again, we were able to rule that out statistically. And we did something, actually John was responsible for this, something where he actually was able to derive what we call counterfactual fisheries. So one fishery that adopted a catch share that had all the same kinds of characteristics as a fishery that did not adopt a catch share, and look at the difference between those two things. Again, we got the same result. And whether you look at small or large fisheries, you get the same result. So over lots of kinds of robustness checks, you get the same thing. And then we did this sort of simulation where we said, based on the statistics of our analysis, suppose in 1970, all fisheries in the world adopted catch shares, and that their success was the same as what we've observed historically. And what you get is, well, if you don't adopt catch shares, this is what you get. And if you had adopted them in all the fisheries, this is what you get, sort of a flattening out or even a slight increase, slight reversal. That's sort of the ecological result, the effect on collapse. what about the economics of the situation? Well, there actually have been fewer analyses and fewer empirical analyses of the economic effects of catch shares. A recent report from the World Bank estimates that about $50 billion a year is lost due to mismanagement of fisheries. And another recent report by Jim Sankiriko and Jim Weiland says, well, if you were to recover fish stocks that are currently collapsed, that number could be as high as $90 billion a year. And Corbett Granger, who's a PhD student over in the econ department, is compiling a really interesting database of all the catch share fisheries around the world and their profitability. His preliminary results show, anywhere from a 2 to 4-fold increase in profits as soon as you switch over to catch shares. So very positive and encouraging initial results. This is my last slide. And I think one of the main arguments you hear against catch shares is that it's privatizing the oceans. Okay, people say, oh, it's privatizing the oceans, I don't like it. And to me, that presents a paradox. Okay? And the paradox is that we've tried the experiment of full public control and not giving any control to the fishermen. And we failed. The more public control you have, the less security you give to the fishermen. And the less security the fishermen have in their rights, the less they're willing to invest and steward the resource. Okay, so I think it's time that we kind of got over this argument that privatizing the oceans has to be bad and start thinking about what is the role for science, what is the role for oversight in these kinds of catch share systems. And I guess I just want to conclude with my own personal feeling that, I don't think we should think of catch shares as a panacea for all of the world's fisheries problems. There are cases where catch shares won't work or where you have to design them in a certain way to achieve certain objectives. But the key really is just smart design. You have to determine what your social, ecological, and economic objectives are, and then you have to tailor the design of the catch share system to achieve those objectives. And it pays to go look around the world because lots of these things have been tried, not just the ones I showed here, but hundreds of others. And you should look for the successes and look for the lessons in those things as we design new catch share systems. That's all I've got. Thank you very much.